Hello everybody and welcome back. Today's video we're going to show you how to take this Syma X8 quadcopter and we're going to modify it to work with these brushless motors. It's going to give it a lot more power, it's going to give it a little bit more lifting capacity, and it's going to make it much faster. It's going to be the simplest video that we can do. It's going to be step by step. We're even going to reuse the factory receiver board or flight controller that's inside this. So this is going to be, I hope, the cheapest way, but also the most basic way of making this work, and it's also going to let you reuse the factory transmitter that we're used to flying with. So the first step is we're going to have to take this thing apart and get into the inside of it where we can start making our first modifications. So let's go ahead and get started. Uh-oh. That's not good. Good thing we're replacing them. Most of the parts, you've got the props off, you've got the landing gear off, you've got the bottom motor covers off. What you'll want to do is take a razor blade and just carefully cut through these stickers here right on the seam. I don't really like pulling and peeling on them because you'll never get them to stick back, so just cut through them. To remove the top cover from the bottom cover, there's going to be 3 screws at each corner of the quad, and there's also 4 screws here that hold the shell together. These were located underneath the landing gear legs. So take apart all these screws and we'll be able to separate the top cover from the bottom. Okay, here we are. Just took apart all the screws. With it turned upside down, the motors just basically fall out. So we'll get all this stuff out of here. So now we have our top shell completely bare. The only thing we're going to need to do to this to modify it is to open this plastic up at the top here to give more room for the motors to sit inside there. So we have the bottom of the unit. You can see the power wires that head out towards each motor. You also have the LEDs at each arm with the tiny wires that connect to that. You've got the main receiver board here in the middle, and you've got a small switchboard and camera plug at the bottom, and of course you have your battery bay at the bottom. The next thing we want to do is we want to pull everything out of here. We want to take the LEDs out, we want to take the board off. We also want to take this plastic board at the bottom here that this bolts to. We want to take that off as well. This right here is the front of the aircraft. So when your 4 power transistors at the bottom here are back here, that is the front. When we go to put this all back together, this does have to be positioned properly. The compass on board knows which way is forward, so it's a good idea to make sure this is going to sit back in this direction. Okay, so we have the main flight controller board out of the aircraft. At this point, we're going to want to do a couple things to this. We're going to desolder all of these main motor leads because we're not going to be using these anymore, at least not with these wires. I'm also going to remove the LEDs because I'm going to power these later on, not using this board. So I'm going to remove that. I'm also going to remove this switch and the camera connector. If you're going to be reusing your stock camera, you can keep this. I'm going to be using basically a GoPro style camera, so I'm going to just disconnect all this, and where these switching wires are that turns the unit on, I'm just going to put a little jumper wire between that. So anytime the battery is plugged in, basically at that point the aircraft is turned on, and that's how I can eliminate this board. You want to do yourself a favor here and go get a butane powered soldering iron. I really hate electric soldering irons. They just suck. They don't get hot enough. They're too bulky. You know, this is nice and small. I've got a nice little pointed tip that I can use to get in even some small connections. So definitely worth it to buy one of these. Okay, so once you've removed all the unnecessary components, you'll end up with this, just your flight controller board with the main power lead coming in and the tiny little crappy antenna wire coming out, and that's going to be our starting point. Okay, the brushless motors I'm going to be using for this build are made by Ghoul RC. They're 2212 950 kV motors. There's a left hand and a right hand thread pitch on each of these threaded ends here, and what we're going to do is we're not going to use this prop nut here, but we're going to use a twist-on self-tightening prop that you can get for the Phantom 2 or Phantom 3 series of quadcopters. These motors are actually a direct replacement for those, but we're going to be using them in our build. Now for the speed controls, we're going to be using this unit. It's a 4-in-1 electronic speed control by Emax. And it basically has 4 25 amp speed controls on board. It's quite a bit bigger than I thought it was going to be, but we have everything contained in one unit here, so it's going to be a nice clean installation. It was only about maybe 10 or 15 bucks more than buying the individual ESCs, but for this build I really wanted it to be as clean and as simple as possible. So if you compare it to the size of this, it's big. It's a lot bigger than I thought it was going to be, but I have confidence that we're going to be able to get it to fit and work just fine. And for the simplicity of this, as well as just the cost of it, I think this is a reasonable option. On my last video that I did, I used 4 individual speed controls, but I had them in each arm of the unit here. And the problem with that is when you take these landing gear legs off, there's a screw going between each arm here that holds the body together, and I had to remove those screws in order to make room for the speed controls, and that ended up greatly reducing the strength of the body. So I didn't want to have to do that again. That's why I decided to use this unit that's going to be mounted centrally in the center here, and we're hopefully going to avoid the issues that I had last time. Now to make this all work with the factory receiver board, we're going to need 4 of these. These are brushed to brushless signal converters. It's made by Extreme Productions. You can buy different brands of these online if you look around. They're getting a little bit harder to find, but they are out there. Basically what this is going to do is convert the pulse width modulated signal that comes out of the Syma's flight controller, which is a 2-wire power and a ground basically, and it's going to convert that into your standard sort of servo signal that the speed control is going to need to function. These are an absolute requirement if you're going to be reusing the factory receiver. Now one of the things I like to do is to modify the antennas on these. We're going to get a little bit better range, especially if we're obstructed by trees or there's something in our direct field of vision. All these are 2.4 gigahertz Wi-Fi antennas. You can find them everywhere online. These are 2 dBi. You want a 2 dBi. You don't want to get a 4 or a 6 or a 9 or a 10 dBi, because all it's going to do is it's going to basically narrow your field of vision that this signal can output. You'll get a stronger signal if you're in it, but unless you're pointing the antenna just right, you can lose signal. So a 2 dBi antenna is going to give us an all-around good signal regardless of which way we're pointing the transmitter. To make these connect to the board, we got 2 standard RP SMA connectors. They're basically just for Wi-Fi antennas. Just like the antennas, you can find them anywhere online. Just type in RP SMA. And so we have two connectors, one for the transmitter and one for the receiver board. Now to mount everything to this aircraft, I bought this. This is just a sheet of carbon fiber. It's a real carbon fiber. It's a 1.5 millimeters thick, so it's not terribly thick or anything. It's super lightweight. It's very strong. It's also very easy to cut, and we're going to be able to basically mount everything to this, and we're also going to use it as a reinforcement where each of the motors mount to the body of the aircraft, because we don't want to just screw them right into the plastic. We want something a little bit stronger than that. Just for this tiny little sheet, it was about $30. It's made by Eris. You can buy it on Amazon.com. If you don't want to spend $30 for a little sheet of carbon fiber and you want to do this a cheaper way, just go to your hardware store and buy a small sheet of Lexan or polycarbonate. Basically, it's just a plastic sheet. It's going to perform about the same, not quite as strong. It might be easier to crack it if you're not being careful with it. But I really recommend carbon fiber. It looks awesome. It's very strong, very lightweight, and it's going to do exactly what we need it to do. Okay, since I'm no longer using this receiver board to power the motors directly, I'm basically just using it to output signals. I didn't have to keep this large heavy wire on here anymore, so what I did is I used one of the old wires for the motors and connected that as the main power input, and this is going to go to my voltage regulator that's going to output the 7.4 volts that this board needs to work. So just kind of trying to keep things lighter and easier to work with. Now the next thing I'm going to do is I'm going to solder on each one of these brushed to brushless signal converters at all 4 channels of the board. It's important to note right now that there is a positive and a negative. The nice thing is on these boards everything is really clearly labeled, so where it says motor 2 right here, or M2, positive is on the left here, it says M2 plus, and our negative is going to be right here where it says M2 negative. So basically the same thing goes for all 4 channels. Alright, so at this point I soldered on all 4 of these brushless signal converters to the stock Syma board. So right now, if you had speed controls and brushless motors already mounted up to the aircraft, you could simply plug these into each speed control, and now this board would work with your factory, with your aftermarket speed controls and motors, brushless ones. Alright, now the next step is I need to prep the speed control with the correct wiring, so I'm going to solder on my battery connector now directly into the speed control. But what I'm also going to do is I'm going to tee off a smaller gauge wire in parallel with this, so that my battery feeds not only the speed control, but it powers backwards to my little voltage regulator board, and then that is going to power my factory receiver. So here's the finished product. You can see my battery connector is soldered directly to my speed control, and I have a smaller wire coming off here that will go to my voltage regulator board that will feed the factory receiver. Okay, so for the next step here, what we need to do is to modify the body of the aircraft, and what we're going to do is on each leg or arm of the aircraft we need to use a rotary tool and basically level out these parts that are sticking up here. We want a nice flat area to work with. We're not going to touch this part or these 3 parts because that's where the screws are going through, but we are going to buzz down this whole section right here. So I'll go ahead and take care of each end, and we'll take a look and see what we have after that. Alright, so what we can see here is I took out the structure on the end of these arms. You can see now how it's all basically flat here except for these three screw holes. So this is what we want. We want it to be nice and flat, and we've now have a perfect starting point that we can use to mount the new brushless motors on. What I used to cut this out with was a Dremel and a carbide bit. So the carbide bit that I use by Dremel is this. It's a 196. You can get them at most hardware stores that sell Dremel products, but this one in particular has a flat end on it, so it worked real well for getting into the plastic and carving off only what I needed, and it didn't really have a tendency to skip across the plastic or anything like that. It was a real nice controlled tool to use for this job, so it worked out really well. I would definitely advise using this. I wouldn't advise using a cutoff wheel or a razor or anything like that. This really does the job very well. So what you can see here is now that I took away that plastic, the brushless motor, when I center it up against this hole, which is already existing there, now the motor sits nice and flat on here. We couldn't do that before because of all that structure that was there. So at this point you could theoretically bolt it in, but what we're going to do now is on the back side here we're going to make a piece of carbon fiber bracket that will sandwich the motor and the aircraft together. It'll make it really strong, and that way the bolts that hold the motor on aren't going to be pressing right up against the plastic itself. Okay, so the next thing you have to do is take your brushless motor and just kind of set it on the back side here, centered with the existing hole in the center. And what you'll have to do is take a look at where these holes are sitting. You'll have to move the motor around a little bit, and each of these mounting holes, the threaded holes on the bottom of the motor, you're going to have to outline on the plastic what you'll need to take away so that you'll be able to access the bolts from, or the bolt holes from this side of the plastic. So you can see on each one of these legs here, I've already done that. I basically just outlined the plastic that I will have to remove. Okay, so what we can see here now is you'll take a look at this motor and see these 4 threaded screw holes here. Now, with the plastic that I have removed, when we line this up, you can see now that those holes are accessible. That's what we want. Next step now is we're going to make that carbon fiber plate that's going to inlay in here, and that's going to sandwich this whole end piece between that and the motor and increase the structure back here that'll be adequate enough to hold this motor. As it is right now, there's not enough structure here, so we have to make some sort of plate that's going to hold this piece on correctly. Now the bit that I used to carve out these little center pieces in here, I used another bit that fits for a Dremel. It's kind of a universal cutting bit. This was skinny enough to get in here and widen out these holes like that, so it worked very well. I would recommend it. So what you'll have to do for this step is you'll have to make some sort of template that's going to fit in here. Now I'm kind of cheating a little bit on this one because I've already made one of these conversions before, so I have this piece I can reference from, but basically what I did is just cut a piece out of cardboard and kept fine-tuning it until I got it just right, and it ended up with this. So this is going to lay in here like so, and so you can see I can still access all the screw holes, but this is going to sandwich in between the aircraft and the motor. So I'm going to transfer this into carbon fiber and make 4 copies of that that'll fit this. So this might be kind of hard to see, but I used that template to scribe some lines into this carbon fiber. I just used a razor to scratch it into the surface. So now I'll go use that Dremel rotary bit and I'll cut these out. So if you check this out, these are my pieces that are done in carbon fiber. So I used one of those rotary bits to carve out the inside here. I used a drill bit for the holes, and I used a little micro cutoff wheel for the Dremel to cut the rest of the shape out. So all we have to do now is bolt everything together. The brushless motors, if you got the bolts or the hardware with it, that's great. If you didn't, they're going to be a metric M3 bolt. So I should note at this point that we're ready to bolt these motors in. I explained earlier that there is two different thread pitches. There's going to be a counterclockwise and a clockwise thread pitch. That depends on which way the motor is turning. So when the motor is turning, you want it to self-tighten the prop. So to figure out where these are placed on the aircraft, you'll have to take a look at the top cover here. At each corner, it'll show you which direction the motor should be turning, and so it'll be up to you to figure out where each motor should go to make sure that they're going to be spinning in the right direction. A brushless motor can spin either way depending on how you hook it up. So all that's going to matter at this point is the threads that are cut into the top of this motor. That's what's going to matter. I got all 4 motors mounted. If you made it this far, congratulations, because this is definitely the hardest part. I had a couple of my carbon fiber brackets that were fitting a little bit tight. The holes were just a little off center or whatever the deal was, but I was able to get all 4 of them mounted up just fine. So we'll move on to the next step. Alright, so at this point I have all 4 of the brushless motors mounted. I can actually put the cover on almost all the way. I really wish I could make it fit all the way like this, but it does scrape against the motors. So the next thing that has to be done is we need to modify this top shell. So what we're really going to do is we're going to take this top end piece here, and this existing outline where the flat part is, that's what we're going to remove with our rotary tool. So we're going to open this up so that it makes room for the motor. You may have to test the fitment, and you might have to take a little bit of this plastic out on the inside here. It just depends on how it fits. But I'll go ahead and take care of this, and we'll test the fitment and see if it's good. Alright, so what we can see here is I've now modified this top cover, opened this up so that we can now fit the brushless motor. So I've done that to all 4 corners. I used that carbide rotary bit on the Dremel tool to open this up, and then just came back with the razor blade to clean up the edges. So at this point, if I throw the cover on, it all fits down nice and tight. Once the screws go in, it'll be nice and snug, and all these motors spin freely inside the stock Syma chassis. That's what we want. Alright, so what I made now are 2 boards out of carbon fiber, and what this is going to do is to hold all of our electronics into the Syma's frame. So this first board that I made out of carbon fiber is basically replacing this piece inside, which would have normally held the receiver board. So these tiny little screw holes right here are going to secure this to the aircraft chassis. These 4 even smaller holes here are what the receiver is going to screw down to, and then these 2 holes at each side here are going to hold the little razors, what do you want to call it, the little offset pieces that will support the second board, which sits on top, and that is going to hold the speed control. So let's put all this into the quadcopter. Take a look at the board here. You can see I have the factory receiver mounted back where in a similar position that it would have been. Keep in mind that when these power transistors here are at the rear of the board, that's the back of the aircraft. So this is front. I have all 4 of my brushless signal converters attached to the bottom board, and everything is properly wired in place. Okay, so as we can see here, with all the electronics mounted inside, it actually does close up. I put the 4 screws at the center here in. All the electronics fit inside nicely. I will probably be using a battery on the outside of this, but there is still plenty of room to mount the battery inside, which is really cool. And so I'm going to take it back apart and finish up all the wiring so that we'll be ready for our first flight. Wired up, all the motors are wired up. What I need to do is to see which direction these are rotating in. So I'm going to power it up, give it a little bit of throttle, and make sure they're all spinning in the right direction. If one is spinning backwards, I simply have to reverse any 2 of these 3 wires, and that'll get the motor going in the opposite direction. Alright, so here we are with my first unofficial test using the Syma remote control and the new brushless motors. So we give it a little bit of throttle. See that they all work, so set it down and take off.